When I see your faces, I'm aware that we're still in the 2-year worldwide web called the pandemics, which, if nothing else, among all the other bad things it does, it at least made a lot of things connected to work analysis come into the public consciousness. We were talking about content tracing, which is how you create networks. We were talking about super spreaders, which is basically the hubs in the networks. We were talking about lowering the R, which is basically just how to make sure the spread over the network can be lowered. So what exactly is network analysis? Network analysis is basically it's separate from the more other data analysis things like machine learning or text analysis, and it deals with basically any things, objects, people, and the relationship between them. It can be used to not just research pandemics, but it can be used to figure out how resilient the electrical grid is, or what the connections between the countries are, or how likely these relationships are to last, or to analyze historical trends by seeing which people get along with each other. But as all these are hard problems, which we cannot solve with technical decisions only, I prefer to do something a bit more fun. So this is why I would rather present these two examples of analyzing fan fiction than any of the more seriously stuff. So what's a fan fiction? Let me do a quick question. Who here reads fan fiction? Oh, so about quarter, fifth? Okay. Is any of them here who writes them? Okay. A lot less, but no, for the rest of you uninitialized people. Okay, should I first ask a question? Who knows what a fan fiction is? Okay, so is there anybody who doesn't? Oh, okay, we do have uninitialized people. Fan fiction is basically when you have, I don't know, a movie, a series, a book, real life people, and you're just unsatisfied with what you're actually seeing. So you can see a movie and you're dissatisfied with how it ended, or you can see a series and you wanna explore more some of the people which were neglected in the series, or you see a real life people and try to figure out, are these two people really together, and if they are, what they would be doing? This is where the fan fiction comes in. They're basically stories that people write in order to explore things and to sort of figure out how things could be different and exploring their creations. So today we are gonna be researching the Harry Potter fan fiction, and I'll try to explain the basics of the network analysis through some of the examples that I'll do. The data set that I'm gonna be using is the Archive of Our Own is one of the bigger fan fiction sites in the English language internet, and they were nice enough to last year provide all the text stories data in the easy to consume CSS. Okay, the tab data. Okay, my English is bad. And this is the data that we're gonna be using. So when you try to create a network in the Python, first you would define that you're creating a network, and you would define all the relationship and people in the network. So let's start with what the network is. This is the network of the 50 most popular pairings in the Harry Potter world in the graph. So when you talk in the network analysis, you have two of the main concepts. The first are nodes, which in this case are like people that appear in the Harry Potter fanfiction. So you have most of the normal ones, from Harry Potter to Hermione Granger to Tom Riddle to Sirius Black and so on. And then you have edges, which are basically the connection between the people, and in this case it means are these two people one of the most popular pairings that exists? So in the network analysis, you actually can have different types of networks. In this one is so-called unordered one, because you cannot know, if the two people are in a relationship. If the A person is in relationship with the B, then the B person is also in the relationship with an A. At least, as far as I'm aware, it still works like that. You can also have an unordered one, which would be, what if somebody is, for example, in love with somebody? That doesn't necessarily have to be that the other person is also in love with them. That would make for an ordered graph, and you would usually indicate that by having an errors from one person to another to indicate which one influences the other one. You can also have graphs depending on how important the connections are. So in this case, you could say, okay, all of the different relationships could be of the same importance, or the more popular one could be of a bigger importance than some of the least popular ones. For example, in the Harry Potter world, I think it's pretty clear why Harry and Draco relationship it's a lot more important than Horrocks' Harry relationship. That exists, because I saw somebody being surprised. And then you can also have types of graphs of whatever you can have multiple connections or whatever you can connect to yourself, but we are not going to be talking about them at all today. So when you are describing a graph, you can usually get some easy metrics. You can get, for example, number of nodes, how many people are actually involved, or you can get how many different relationships are in a graph. You can sort of get a density, which gets you how many connections the people have on average, because most graphs have a very small number of connections, but if you look like on the Facebook graph, people tend to have a lot more connections, and this fanfiction one is somewhere on the middle. Then you can also see how long would you take to get from one person to another, or things like that. I was lying when I said that this graph before was the whole graph. This was actually the whole graph. You do have some of the things that are stranded, and this is the first thing in the graph networks. You can usually have disconnected components in the network graph. So you can have a lot of people connected, but you can have some stragglers. For example, here you have a new generation. Here you have Dumbledore, who apparently isn't paired with so many people, and so on. And some of the analysis in the network analysis you can do with the whole graph, but for a lot of them you actually need a connected component. And usually what is taken is the biggest component there is, and it's usually, you can figure out which one is the biggest one, because they can get more than that. So you can see, this is how you can get the connected components, and you can look through them to see what people are connected between each other, but not with everybody else. So now I took all the reoccurrence of all the characters that appear in Harry Potter fanfiction, and I looped through the smallest components. And there were some interesting things that I found out. The first one that, anybody aware of the story of the Christmas spirit, when there is, okay, some of them are nodding, there is like a person who's really greedy, and then he's visited by the ghost of past and the present and future, and then changes his mind. That appears in Harry Potter fanfiction by itself, not connected to anything else. Yeah. These are the connections of, at least all of them seems to be historical people, most of them English nobility, but some of them, you know, you have like somebody from Luxembourg and so on, that also appear in Harry Potter stories and not connected to any of the Harry Potter characters. But I was the most surprised by this. Okay, I see we have, you know, male public. I was figuring you would recognize that. Yeah, was surprised about that. Did recognize it on the side. Not entirely sure how to explain that. Yeah. If you have a question, I'm willing to take questions during the... Well, yeah, they are stories connected to Formula One people, where in the Harry Potter settings, I'll let to your imaginations what these stories are actually about. So, when you talk about the networks, one of the things you want to know is who are the most important nodes in the network. And this is because normally when you talk about the network connections, you want to know which one are the one that get most information from or they're important so the networks don't get disconnected in multiple components and so on. Though there is a pretty interesting research that that if you're talking about human networks, these are usually the people that also stop the change. So because they get influenced by so many different environments and nothing can be the prevailing influence. So in this case, it can also be good to know who are the people that you actually have to put more energy in. Yeah, and we are going to talk this about on the trope that's actually close to my heart, which is BAMF. It's an acronym which means badass motherfucker. And, and it actually refers to when there is a person who usually will just run then and solve every problem by itself. They're usually like really resourceful and really strong, and it's usually reserved for people that that sort of show some of it in the original stories, but not so much as you would in these stories. I actually really like reading that. So if you look at the networks of the people appearing in the story, seems pretty much what you would expect from a popularity one. There may be a bit more slitherings on this side of the table that what is usually expected, but otherwise you have the normal group, you have the Mauderous group, you have all the extended main cast. So the first thing that you try, when you try to find out the most important person, is a degree centrality. That basically just tells you which is the person with the most connections. So if you try to find out the most important nodes, this is sort of the result that you would get. And it's sort of something you would expect also based on the popularity, more or less. The between centrality on the other side tries to see which are the nodes which are important to connect different types of groups. So for example, let's say Hermione Granger and Voldemort fall in love. They would suddenly become a node that would connect to entirely different groups that otherwise wouldn't really be well connected. And this is what the betweenness centrality shows, and the numbers indicate what was the rank on the previous measurement. And you can see that in this case, you usually have a pretty similar rankings. What's probably surprising is the original characters, which are used a lot in fan fiction and can be a lot of times used to connect different groups simply because you can be used with basically any story or any other characters. The third centrality is page rank. So if the degree centrality just try to check the number of connections, what the page rank tries to also figure out is how important are these connections. So, for example, a person that visited Dursleys in the second book is probably pretty important in their own world, but is an absolutely non-important character in the Harry Potter world because he doesn't have any important connections to the most important people, even if it has to all the other ones. On the other hand, Luna, for example, doesn't have friends, doesn't have a lot of friends, but she's friends with the Harry Potter, which makes her a more important character. And you can again see that these lists doesn't really change much. And if you actually correlate them, in a lot of cases, the different degree centralities would correlate quite a lot. Though it's not necessary, I also saw negative correlations. So it's still important to check which centrality, for example, do you want, because degree centrality, for example, is a lot quicker to calculate, especially for the bigger networks than, for example, in between centrality. So, next question. How to pick nodes and edges? When you're doing network analysis, it's sometimes important to figure out what are you actually trying to analyze. So how do you pick which are the actual people and which are the actual object of analyze and which are their relationships? So for example, I started with the graph of who is in the relationship, and then we get to graph of who actually appears together with the story. So for this, I'll use an example tag of Remus Lupin needs a hug. Needs a hug basically means a story when somebody gets in a really bad, a lot of times abusive relationship, and then you write a story when you usually just mention that or describe it, and then somebody consoles that person, and that person gets a happy ending, and so on. In the Harry Potter world, on this side, the people that get this tag are actually Harry Potter, Draco Malfoy, Remus Lupin, and Sirius Black. The rest of the people apparently don't deserve this treatment. Yeah. So, for example, what I wanted to see, how can some of the tags be different from the general Harry Potter fandom? So are there any relationship that appears more frequently than what you would expect from the relationship appearing in the general Harry Potter relationship graph? And this graph basically tells you, in this tag, these are the relationships that are prominent here, but not really prominent in the normal Harry Potter fandom. So you basically see a fairy tale one. You see there, you have Winston Churchill, a character from Wonder Woman, Dracula, and Jim Gordon, which I have no idea what they have in common. You have, for example, stories that connect to Potter family taking him in or being raised by wolves and so on. So you can see, by deciding the edges of a relative importance, you can actually also see differences between fandom and sub-fandoms. How much? Okay, cool. Okay, the last point. You can also try to find the community. So these are like types of graphs which are more divided, which are more closely connected with each other than with the rest of the graph. And for this, I'll use the example of alpha, beta, omega, which is a trope in fan fiction, which in where the people have secondary gender. So if you have an alpha gender, you're usually very protective, very strong, very aggressive and so on. And if you have an omega gender, then you're usually submissive, or you have some sort of weakness, you want to be protected, you want to be taken care of, and so on. So if we take how is this stack different from the rest of the Harry Potter fandom, we get a graph that you can see can be pretty easily divided into communities, even by the eyes. So I want to go through the 4 main communities that this algorithm finds. So this is the first one, which is a normal Harry Potter one. You can basically see a lot of Harry Potter characters, including some of the rarer ones, like the giant squid, and a couple of random ones thrown in. The next community it finds, it's another trope in a fanfiction, which is a reader fanfiction. It's a fanfiction which is written on a way that the main character is as characterless and as faceless as possible, so a reader can live the fantasy through their eyes. And you can see the reader with many different people from MCU like Peter Parker and Wade Wilson, to token stories, to actors like Chris Evans and Tom Hiddleston, to some of the games and so on. The next one is this one. In this stack, a lot of some of the DC characters also appear. Considering which ones are appearing, I'm assuming from the Arrowverse community. So this is the third one. And the fourth one is the Marvel Universe, which apparently this stack inside of the Harry Potter fandom is also popular. Crossovers are something I really enjoy, so I'm really happy to see that. How much time do I still have? Okay, cool. So, so for conclusion, my main goal with this talk was to hopefully give a sort of a gentle and interesting introduction to the network analysis to people that might be interested in using. Because I think that while the machine learning and text analysis are pretty well represented, some of the other ones like network analysis or genetic algorithms and so on are a lot of times overlooked. And the secret reason was that I recently discovered that a lot of people internet is actually really normal for some people, and what I experience of the internet is actually weirds people out, and I was trying to see if I can sneak some of it in. So you can tell me how successful I was at that. So thank you for listening.
Thank you very much, Sara. Do we have questions?
So thank you very much for your presentation. I arrived a bit late, so maybe I missed this part. In case, I am sorry if you told this before. But I was wondering, how did you build the networks? Like, did you parse the huge amount of text from the archive?
No.
Or there was like already a model of some kind?
They provide, last year they provided the data of all the stories and their tags in the tab data for easier parsing, and I use these tags to then develop the network. So I use the relationship tags to develop a relationship network, and I use the co-occurrence of the character tags to develop the character networks.
Okay, I have one question.
Yeah.
Do you have an idea of any other network analysis package in Python apart from Network X?
They are, but I'm not gonna remember out of hand which one are they. I don't know, for a Python I use this one, and my mentor at the university uses a Java one, so I don't know if there's any. So I know that they are other in Python, but I cannot tell you which ones they are.
Okay, thank you. I think I've heard of Java before. Thank you very much.
Yeah.
Do we have any other questions? Please let's have a round of applause for Sara. Thank you very much.